So today we're reviewing to get ready for our quiz. First thing we're going to talk about is how to graph some inequalities. So remember how to read them first. Y is less than or equal to 2. So you're going to make your number line. Remember, number line needs arrows on it. Needs a hash marks to represent where the numbers are. And here we don't really need to go out very far. So first we start with the 2. Is 2 less than or equal to 2? Yes, it is. So it's included. So we need a colored in dot above the 2. Then all numbers less than 2, would they be 3, 4? No, they would be the 1, 0, so they'd be going this direction. Again, read it first. X is greater than negative 1. So make your number line, put a few numbers on there. Is negative 1 greater than negative 1? No, it's not included. So when it's not included is the open circle. But 0, 1, 2 are all numbers greater than that, so it would be going this direction. Number 2, we're just going to simplify these, and most of these are going to be easy enough that we should not use a calculator on. Square root of 25 64, so we think of it as square root of 25, which is 5, over the square root of 64, which is 8. Now, if that would simplify like it were 6/8, you would need to reduce it, but that one won't. What's the square root of 19 squared? Well, you don't really have to figure anything out. You just know it's going to be 19. Square root of 0.49, well, we know the square root of 49 is 7, so we have to figure out where our decimal goes. So we have 2 places to the right of the decimal, so it would be 0.7, because 0.7 times 0.7 would be 2 places to the right. Now these we're probably going to need our calculator on, and it does say round to the nearest hundredth, remember, so the hundredths is 2 places to the right of the decimal. So if you take your calculator and find the square root of 257, you're going to get 16.0312 and some other numbers. I didn't write them all out. So the 3 is in the hundredths. We'll look to the right. The 1 says leave it alone because it's less than 5. So 16.03. Again, this one we have the plus or minus sign, so we need to make sure we have the plus or minus in front of our answer. Put 195 in your calculator, you're going to get 13.9642 and some other numbers, but right here's the hundredths. 4 says again leave it alone, so plus or minus 13.96. So don't miss these because you forget the sign. Here we know we're going to have a negative in front of it. Square root of 625, that's one you might know. I don't know, but it is 25, so it is a whole number. We didn't have to round on that one. Name the 2 whole numbers a square root is between. Now I do expect to see a little work on this, and it's thinking about your perfect squares. So if you can't remember the perfect squares, remember you just go back and you square all numbers. Just starting with single digits like 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. And hopefully you can just kind of think about them, but if you need to write them out, write them out. So we're looking at for a perfect square on either side of 18. Well, 16 would be on this side, and then 25 would be on this side. Now that's not what the square root of 18 is between, that's what 18 is between. So now we need to take the square root of each one of these to get that the square root of 18 is somewhere between 4 and 5. So I do want to see the perfect square. So 87, what's a perfect square on either side of it? 81. And 100, so when we take the square root of everything, we get it's between 9 and 10. Now this time it says name the whole number closest to the square root. So we actually start the same way. We're looking for a perfect square on either side of 75, so it would be 64 and 81. But now you have to figure out which it's closest to. So 75 minus 64 is 11, whereas 81 minus 75 is 6, so it's closer to this side, so the square root of 81 is 9, so it's closer to 9. So I would expect to see the perfect squares on each side of these that you're showing me, so that I know you understand what you're doing there. Name the set of numbers to which each belongs. We have natural numbers, which remember are just kind of the counting numbers. Oops, sorry, I need to go back. One more. Oops, we're ready. All right, so set of numbers to which between natural numbers or counting numbers like 1, 2, 3, 4. Whole numbers are almost that. They include 0. Integers are whole numbers and their opposites. Rational number, any number that can be written as a fraction, and that does include repeating decimals. Irrationals are numbers that go on forever without a pattern. So any repeating decimal is a rational number. -5, is it a natural number? No. Whole number? No. Integer? Yes. Can it be written in fraction form? Yes. So it is a rational number. Square root of 4. First we need to simplify that. Square root of 4 is 2. So is 2 a natural number? Yes. Whole number? Yes. Integer? Yes. And it can be written in fraction form, so it's a rational. Square root of 150, if you check that on your calculator, it does not come out even, so it is an irrational number. put these numbers in order from least to greatest, and we need to show our work. What showing the work means is just showing the equivalent of these. So if we change negative 3/4 into a decimal, it's going to be negative 0.75. If you take the square root of 2, you're going to get negative 1.41. The other two are already in decimal form. So remember, we're talking about the least, so we want, if you think about a number line, and here's 0, the farther it is, so the bigger it is negative-wise, is the smaller it is. So which one of these numbers is the biggest? So you look at all of them, so which is the biggest? Negative 1.5. So negative 1.5 would be my smallest number, because it's the biggest, and we have the negative sign in front. Then would come this one, but we need to write the equivalent of it, which is negative the square root of 2. Now to compare these two, remember, you need to remember what this means. This means 7, 7, so the 7s are continuing. So 7 is bigger than 5, so that would be the next one, negative 0.7. Bar over it, and then last would be the negative 3/4, would actually be the biggest of these numbers here. A couple of questions that make you think a little bit. When you add a rational number and an irrational number, the answer will be, well, remember what a rational number is. It kind of ends, right? So, or it could be a repeating decimal, but an irrational number goes on forever. So if you add something to it, is it going to go on forever? It's going to stop. It's going to go on forever still. So the answer here would be irrational. When you multiply two rational numbers, the answer will be, okay? So again, you're taking two numbers that end, or repeating decimals, and when you multiply them, they still are going to end, so it would be a rational number.